Good morning, all of you. I, Dr. Badrinarayan Mohapatra, Assistant Professor, Instrumentation Engineering Department of AISMS IOIT Pune. Today we'll be discussing control system. So in this control system, we are discussing about steady state error. What are the different type of steady state error? What is the formula for steady state error? And what is static error coefficient? So in the steady state error, the definition of steady state error is that it is the difference between the input and output of the system during steady state. We know that output by input, that is E of S by R of S, is equal to 1 by 1 plus G of S H of S. But the steady state error, which will be obtained by final value theorem, so that formula of steady state error, which will be represented as ESS, which is equal to limit t tends to infinite E of t is equal to limit s tends to 0 s multiply with E of s. So this is all about steady state error formula ESS, but limit s tends to 0 s multiplication with R of s divided by 1 plus GSHS, but here H of S is nothing, that is feedback system. If the feedback system is 1, that is H of S is equal to 1, then ESS is equal to that formula which will be reduced to limit s tends to 0, that is S multiply with R of S divided by 1 plus GS. That steady state error depends on the input and the open loop transfer function. But when we are discussing about static error, so that static error coefficient is of three types. One is static position error constant Kp, second one is Kv, that is velocity error constant, and third one is Ka, that is acceleration constant. So whatever that static error coefficient, suppose someone will be find that static position error constant. So suppose someone will be using as a unit step input. So particularly for unit step input, one should have to multiply 1 by s. So whatever the steady state error formula, so one should have to be multiply 1 by s, because we are considering as unit step input. So by putting in that steady state error formula, that formula comes as a 1 divided by 1 plus limit s tends to 0 g of s h of s. So where this proportional constant Kp, which will be defined as limit s tends to 0 g of s h of s, and this is the proper way of calculation of static position error constant Kp. Similarly, the next point is Kv, that is static velocity error constant. So basically, when you are considering this velocity error constant, if suppose someone will be considering as a unit ramp input, so particularly for that we need to be multiply 1 by s square. So whatever that formula of steady state error, so in that case we have to be only multiply 1 by s square. So that the equation also change. So at the end we need to be write ESS is equal to limit s tends to 0 1 by SGS HS is equal to 1 by Kv. So Kv is equal to limit s tends to 0 SG of S H of S, that is nothing, that is static velocity error constant. And lastly we will be discuss about static acceleration error constant. So in this case, if suppose someone will be giving as a unit parabolic input, so particularly for that we need to be multiply 1 by SSQ. So same formula we have to be apply here also, but the output which will be changed as a 1 by Ka, and Ka will be defined as limit s tends to 0 s square gs hs. So this is all about static acceleration constant. So in this lecture we are discussing all about different static error constant like K acceleration, Kv velocity, and Kp positional. Thank you.